Hello, Mr. Worth. I'm going to be doing my modern physics reassessment, and once again, this is Usman, Najam. So let's get started. So this is the first thing I'll be showing. This is when these are one of the questions where you get these bars, and you have to figure out the unknown substance, which two, or most of the time it's two, of these elements or these letters. The bars, whichever one can fit into these. And so you want to look at the stripes, and you want to find three stripes. So let's see, the first one has two stripes. That could be a fit. This one could also be a fit because it has one. So all of these, just looking at the first one, could be a fit. And then looking at the other bars, you just have to take your time, and you realize that A and B are the only ones that can work together, and it's a fit. So based on the comparisons, which two elements are found in the unknown samples. So that's what we were just looking at, and it's A and B. So this is our next question. A photon is emitted from an excited hydrogen atom. It has an energy of 3.02 electron volts. What is the electron energy level transition produced from the photon? So you want to use the formula E, change in E equals E final minus E initial. And then you want to go to the reference table, the page that has energy level diagrams, and you look at n equals 6 equals negative 0.38, and then n equals 2 it equals negative 3.4. So you plug that into the formula. So it's negative 3.4 electron volts minus negative 0.38 electron volts, which gives you negative 3.02 electron volts, which is what you want. So the answer would be from N6 to N2. Okay, now I'm going to be showing characteristics of waves, or so light is a type of wave, which is how it's related to modern physics. So polarization of waves. So for this example, when the wave is vibrating up and down, and it passes through like a fence or like an obstruction that has its like fences parallel to it, or the same direction, like it's going up and down, then the vibration or wave can go right through it and it won't be disturbed. However, in the bottom example, the fence is going horizontal and the vibration or wave is going up and down, so therefore it seizes and it gets destructed, and it just goes straight and the vibration stopped. Now, wave diffraction. So here you see the wave, as it goes through a hole, it diffracts. And that's just one of the characteristics. So the greater the hole is, the less the diffraction. So if you have a very small hole like you do here, the diffraction is greater. And if you have a big hole, then it won't be diffracted as much. And then here's an example of where most of the area is just left alone, and then there's a small area in the middle where it gets diffracted. And that area right next to the wall is diffracted more inwards. However, when you get farther out, it goes straight. It doesn't get moved or anything. So this is Einstein's famous formula, E equals mc squared. And so E equals mc squared relates to the amount of energy contained in matter to the mass times the speed of light in a vacuum squared. C equals 3 times 10 to the 8th meters per second is the constant that you're looking at, and that you can find that on the reference table. It's right there. Speed of light in a vacuum, 3 times 10 to the 8th meter per second. So E equals mc squared, and you have 1 kg is given to you. What is the energy equivalent to 1 kilogram of matter? So E equals 1 kilogram times the constant squared, which gives you 9 times 10 to the 16th joules. Okay, next question. Which graph represents a relationship between energy and mass when matter is converted into energy? So you want to realize that you want to use this formula again, and notice that the C is squared, not the M. So E and M have a direct relationship. So as one increases, the other one also increases, which is 1, because 3, it shows when the mass increases, the energy stays the same. It's not affected. That shows when M increases, E is squared pretty much. So like if the M was 2, then E would be 4, which it isn't. It's like if M was 2, then E is directly related. And this is a negative curve, so that's not right either. So as shown in the formula E equals mc squared, it shows that there's a direct relationship between energy and mass, meaning 1 is the answer. Okay, this is more stuff that you don't look at the reference table for, but you just kind of know, or you have to learn. So antimatter is made up of particles with the same mass but opposite charge and characteristics of a matter particle. Antiproton is a particle with the same mass as a proton but has a negative charge, as a positron is an electron, has same mass but has a positive charge. So these are forces that are important to know. So strong nuclear force holds protons and neutrons together in the nucleus. Electromagnetic force, electrical and magnetic attractions and repulsion. Weak force, responsible for radioactive beta decay. And then gravitational forces, attractive forces between objects and its mass. Now I'm going to be showing you this this diagram, which can be found in the reference table also, which is would be found right here, classification of matter. So matter is separated into two things, leptons and hadrons. So leptons would be electrons, positrons, and muons. And the hadrons will split up into baryons and mesons, which baryons have 3 quarks. An example of them would be protons and neutrons. And then hadrons are also split up into mesons, which are quark and antiquarks. Okay, so let's use. There's another diagram or a table that you need to look at the reference table for. It's particles of standard model, and it has the quarks, the charges. So up would be plus 2/3 electron, down to be minus 1/3, and then there's also charm, top, strange, and bottom quarks. And then there are also the leptons on the bottom, like the electron and muon. So those have the charge and the symbols. So let's do a quick question that demonstrates the use of that table. It says, what is the charge of a down antiquark? So when you look at this, down is negative 1/3 electrons. And as we stated before, anti means that it negates pretty much the charge. So the down quark is negative 1/3 electron in charge. So the anti-down quark is positive 1/3 electron. So that's how you do it.